Welcome to droidCon New York again. My name is Jon Markoff. I'm a developer advocate at Google. I focus on security and enterprise. You might notice today that we have a few security talks as well as enterprise talks, and anything from learning how to reverse engineer your app to getting a mobile scan with Now Secure tomorrow morning at 9 a.m. And yeah, let's jump right in. I apologize for the late start. So today we're going to go over a few things. One of them is securing your app with Jetpack Security, talking about some anti-phishing techniques, and also some advanced and enterprise configurations. So before we get started, has anyone tried to use the encryption libraries on Android? How was your experience? Yeah, so I had the same experience, and I actually worked with some of the folks who wrote some of it, so completely understand that. So does anyone know what's wrong with this Stack Overflow post right here? So when I looked into this, about a couple of years ago, or maybe a year and a half ago now, one of the things I noticed was that there's pretty much no help online, and the help that is there is really bad. So this post is from 2011. This is the most popular Android encryption or AES encryption Stack Overflow post to basically explain how to encrypt data. And the first thing is, but just by the fact that it's 8 years old, it's also warning this is wrong, don't do this, which is not helpful. This is probably one of the most important things that your application could do. And second of all, most of these APIs that are even listed here don't even work anymore, don't even make sense. So it'd be great if we had a better solution to that. So at this year at Google I/O, we announced Jetpack Security, which aims to solve some of these issues. And the first thing really with encryption that's important is key management. So that's understanding how do you lock your data, how do you protect your data, and where do you store your keys? So in the past, when you had to do this, you used something called the AndroidKeyStore. That's still something you use today, except now you have a really easy way to do it with one line of code. So we created a master keys class, and this allows you to use a basically out-of-the-box AndroidKeyStore key. It's AES 256 using GCM. This is one of the most secure things you can use on Android, and it's fast and works well. And also is something that, from a default perspective, we gave it some pretty good settings. And all keys in AndroidKeyStore have an alias, so it's kind of like a hash table or a map. You have a description or a key for each key that you have. If you want to do something more complex, like something like use Strongbox or the trusted execution environment, you can actually set that based on here. So I have some code listed here that basically says, okay, if you want to have your own version of it, or more complex version, you can use Strongbox, you can use device unlock required pretty easily without having to understand how all this stuff necessarily works. Device unlock required is a new feature as a PI that allows you to block key access unless the device is unlocked. So that means that if your device is sitting somewhere and someone's trying to hack your phone or get something off of it, if there's no user present and it's not unlocked, then they can't actually, AndroidKeyStore will fail and will not actually allow you to decrypt or get your data. Another thing that we do with keys is there's a concept of key sets. So there's a master key that is basically the keys to the whole kingdom of your data, and then each file or encrypted or shared preference object that you have has a key set object, which means you can have a list of keys that can be rotated. The reason why you might want to rotate keys is if something gets compromised or you have an issue where you can't necessarily, but you need to change your key or update it to a new one. And you can do that without actually having to change your master key. AndroidKeyStore keys, you cannot actually access the key material directly. So you can't actually do a rotation in that way, if that makes sense. That's why we have a concept of a key set. If you need more advanced configurations, let's say you want to use biometric prompts, so that's like fingerprint or Face ID depending on the phone, or something like confirm credential, which uses the pattern PIN or password, you can do that here. You can use the key guard manager, or you can actually use biometric prompt directly. It all depends on your implementation. Obviously, there are some UX concerns here by using, if you use biometric prompt, for example, every time you open your app or every time you have to give key access, it's going to be a little bit annoying to the user potentially unless it's something that's really needs to be secure, so you don't want to make sure. So if it's like a bank transaction, you probably want to require the user actually be there. And and authorize that use. So the first, the Jetpack Security has two main features besides key management, and one of them is encrypted file, which allows you to basically create a file like you would on Android, except now it's also encrypted at the same time. You might notice that the API is a little bit verbose, which is intentional. There's only one file encryption scheme currently, which is, again, AES 256 with a GCM. The nice thing here, this is also a streaming file, so it's not just a all or nothing. So you can actually encrypt very large files with this. The reason why we actually force you to declare that this is what algorithm you're using, even though we could easily default all this information, is that so in the future, let's say AES 256 GCM has an issue or is compromised in some way, or you upgrade to a new version and now there's all sorts of different options, you won't actually know what you're using before and you won't know how to fix it, if that makes sense. So that's why everything in here is a little bit more verbose and explicit on purpose. But, and again, for files specifically, you can actually set your own key sets and create different ones, or you can use one that's defaulted. So there's two optional fields here, and that's key set alias and the key set preferences name. Key sets are stored in shared preferences. And all file encryption you do is the same way you normally do it with a file input stream and a file output stream. So other than just declaring the object, everything works in a similar fashion. And that same goes for encrypted shared preferences. One of the bigger differences here is that the keys are encrypted deterministically. So the keys and values are encrypted in shared preferences. The big difference here is that every time you encrypt a key, it's always going to encrypt the same way. So that allows you to do lookups. So a search, for example, actually encrypts your search query or your key query and then looks it up with that. One last thing to mention on all the encryption features is all the encrypted shared preferences and files are all tied back. So there's a concept of associated data, AAD it's called. So if you see like a method in like Cypher called like update AAD, that's kind of like metadata. So it's something you have to know about to decrypt your files. So in encrypted files case, it's the associated data is the file name. In the shared preferences case, the file or the key is encrypted with the file name of the shared preference, and the value is encrypted with the encrypted value of the key, if that makes sense. Sorry, it's kind of a tongue twister. But that means that everything is tied back to like the source. So you have to know something about the data to decrypt it. You can't, so if someone like stole your encrypted shared preferences value or grabbed this file, they would have a hard time decrypting it if they didn't know anything about it or know the values of it. So we use Tink directly in Jetpack Security. When I first started this project, I went down the path of using the APIs directly and building the whole suite of using ciphers directly, the KeyStore stuff directly, and we have an internal security team that built this library called Tink, which is cross-platform, and that works across iOS, Android, cloud services, and everything like that, which is really great. And they've spent the last 2 or 3 years resolving and finding all like minor issues in Android, minor issues in Conscript and boring SSL, depending on the library you're using. If at runtime, GMS core might load a different version of Conscript, which uses boring SSL under the covers. So it's kind of interesting to think about like how hard it was for me to try to create that by myself without having an entire team behind it. So we decided to use Tink as the engine, and they're really great. So if there's something else you need to do that's a little more complex, if you need to do sharing keys, like Google Cloud or AWS or something like that, you can do that with Tink. Thankfully, I work on the partnership side as well. So we didn't create this in a vacuum. So I've been working with SAP for about 1.5 years, and we just launched a version 2 of their Android SDK, which is, it's more than an SDK. It's like a whole developer environment, which even includes an Android Studio plugin. So we were able to kind of test this with some of their largest customers, and from an enterprise perspective, like security is paramount. So this is a pretty good vote of confidence that we're doing the right things. Obviously, we still have some more to go on here. There's another company called Supermassive that's based in LA where I currently live, and they're like a hacker collective, and I've been talking to them as well, and they helped kind of vet some of the stuff we were doing earlier on. One of the great things is, because this library is still alpha, so if you have feedback, like please log bugs. I do read them. Sometimes we don't get to reply to all of them or quickly. It's not intentional. A lot of them are duplicates, which is great. So currently the library works on Marshmallow and up. We're looking to backport that further because we've heard that from pretty much everyone that they would like to use KitKat for better support for supporting older versions of Android. One interesting thing there is that the reason why we started with Marshmallow instead of going all the way back to KitKat originally is because of the hardware-backed security. There's no symmetric or like AES keys that allow you to do that for Android Marshmallow. So that's why we're using RSA, and we're going to use RSA for KitKat and Lollipop builds. So it'll be a little bit slower, but it'll still work. So that's why we haven't added that yet, but we're working on it. So the most asked for features besides API level 19 or KitKat is just general encryption, but that's what Tink does, so we're trying to find a nice medium and balance there of what we can do. And then easier use of biometrics and maybe even building biometrics into the library so you can basically, again, one line of code kind of handle all those features. So, I mean, once you save data on your device, you're really not done yet. That's kind of the first part, and there's a bit more to do here because you still have to make sure that the device isn't compromised. The user isn't getting tricked into doing something that they shouldn't. So at Cloud Next this year, we announced FIDO 2, better support for back to Android Nougat, which allows you to use our authenticator application instead of a hardware token as well. So if you have like a Pixel that has a Titan key and an actual button on it for hardware to show that there's a user device or a user on the device that's present, you can actually use authenticator apps as well. So let's say you're a bank and there's lots of apps that can do accessibility screen scraping, password managers, look through dialog boxes, and even a lot of them use web views, unfortunately. So because of the web view stuff, if that's not locked down properly, someone could phish your URLs and maybe serve you something that you shouldn't be looking at, but you don't realize it's not the right thing. So especially with things like banking, people can actually steal your money because of this. So from a FIDO perspective, you have like a registration process. So you take your application and you have to register your Android app and your service with your backend to make sure that like you are who you say you are, and that login or that identifier is tied to that user longer term. So the first thing you do from a developer perspective in your app is you're going to ask for a token, and you're going to create a token and send that to your services. Your bank or whatever kind of app you are will need to perform any kind of verification, so it could be security questions, emails, SMS, even though that's not great, as we know, to have some sort of second factor, second device to know that this is you, because the registration process is very important. That's where you kind of link yourself and your device to say that this is really me, this is always going to be me. Most attacks and most phishing attacks aren't remote, they're usually are remote, they're not on the device itself. So if you have an actual authenticator and you have to have this device to log into something or to authenticate, you can block a lot of these attempts. And then finally, once you have that registration process done, all of your transactions, all of your authentications are tied to that device and that phone. And then you have a SAD attacker. So advanced enterprise configuration. So this is going to look like a very big MISC area, but there's kind of a few things here that we can do to help, besides FIDO, actually authenticate and make sure that your device is not compromised in some way. So if anyone's heard of SafetyNet, it's been around for a little while, but in case you haven't, it helps make sure that you're on a certified version of Android. It's not rooted, and it can also inspect your device and find any kind of malware that might be on there, so it can give you a list of harmful applications if they exist. When you ask SafetyNet for data and it gives you a response, there's two fields that are really important here. One of them is CTS profile match. CTS is our compatibility test suite. That basically means that your device, or the device that's making the request, is an actual known Android device to Google and through our process. And that means that it's not running on someone's computer, it's not a simulator or an emulator or something like that. And basic integrity means that the device hasn't been rooted or compromised in some way. The rest of the values here, the nonce, timestamps, API package, is all something you need to check to make sure that that this response is legitimate, and this needs to be checked off device. You can't really ensure that your app is safe if you're doing all the checks on Android, because if your phone's been compromised, you could also compromise this. So there's a few ways to handle that. One of them is generating a nonce. So on device, you're going to create a one-time use code. This could be anything, bytes, in whatever you want it to be, as long as it's tied to the user that you're using in your app, and as long as it's only used once. You're going to pass that into the safety net client and send that result to your backend. So that means that, so this block that I showed you is going to be given to you by the safety net API, and you need to send that to your backend service to validate. You need to validate the certificate chain, the timestamps, APK name, everything else to make sure that it all lines up and makes sense. Like timestamp, for example, that should be reasonably new and recent. It shouldn't be more than a couple seconds, I would think. I don't know if it is, and it's probably not real. There's another service you can call in the back end that allows you to check and make sure that the signature from Google is actually a valid signature and something that was sent. And then you have to decide how to enforce that. You can block access completely to a user on your backend if they've done something they shouldn't, or you can make things read-only. If it's a banking app, for example, obviously you could maybe make the account view read-only, but you can't send money or transactions because at least you know that someone can't steal money that way, which is one of the bigger issues. Single sign-on, so we've had a lot of issues recently with apps that still use web views for their authentication flows. If you have to use web views still, there are a few valid reasons to do so. You should definitely decouple that from your authentication flow and use Chrome custom tabs for authentication, because that gives you a shared cookie jar and allows you to like log in across all your devices easily, so that if you have two apps, for example, and they both use Chrome custom tabs, at least for just authentication, they'll automatically be logged in, similar to how if you have a Google account, you log into Drive, Gmail, you'll notice that they're just magically there already, and that's because of Chrome custom tabs. So there's a shared cookie state across all apps, like I mentioned. Another feature that we launched recently is called Protected Confirmation, which uses the Titan key built into Pixel phones and coming soon to many more phones. This allows you to, on a transaction level basis, ensure that a user is present on a device. So, for example, if you have, go back to banking because that's probably the easiest one, or cryptocurrency or something where there's a lot of fraud, you can kind of force and make sure that users have exist on the device and are real. So this also requires a backend check as well. One of the more advanced, a couple less things that are advanced but necessary depending on what you're doing is key attestation. So key attestation allows you to check basically everything in your AndroidKeyStore and ensure that it hasn't been compromised in some way. One thing that rooting your phone does is generally compromises keys or can compromise keys. And if you don't know that's actually happened, then that's kind of the issue. So you can do that by checking certificate chains and using a parser on your server side. This is actually pretty complex, so there's a pretty good example and an example application on the developer site, but it's kind of a bit too in-depth probably for this chat. One of the cool things that you can do with AndroidKeyStore is, I don't know if anyone knows that you can share Linux user IDs on apps, so you can actually have apps talk to each other, or actually use the same, share files, share everything else. So if you use the same Linux user ID, you can also share the AndroidKeyStore. So that means that if you have 100 internal company apps or 2 consumer apps that also work together, you can share that with the same shared user ID. You can take those and actually share the KeyStore keys, so you don't have to kind of create them and manage lots of different stuff. So if there's an issue, you know that's all in one place. A couple of quick small things here. The shared user ID needs to have the dot syntax, so it has to kind of look like a package name in Java. If you don't do that, it won't work. I don't know if that's really documented anywhere, but it wasn't super obvious to me at least. And the shared user label has to link to the strings XML file. It can't be a direct literal string put in there. Work profile compatibility. This is something that we also run into a lot of issues on our side, especially from an enterprise perspective. But a lot of apps, especially B2B world, even if your app might be running a work profile. That's a different user on the device. It's decoupled on purpose so that you can have a user and a work experience that's different. So I don't know if anyone knows. Does anyone use the work profile here? Yeah. How well do apps work? Yeah, they work okay because people haven't looked into it enough yet. So there's things like you can't share files and you can't share values across profile boundaries sometimes. This all depends on your company and everything is how everything is set up. The camera can be disabled, file URLs might not work, things like that. So just a few things to be aware of here. You kind of have to write your app a little more defensively if it's somewhat business related. I mean, even like chat apps like WhatsApp have kind of issues like this though, because they're kind of sometimes used in a work context. If you want to be able to inject settings into your app, you can do that with managed configurations. Managed configurations allow you to specify values so that if you're using an EMM or like a mobility provider that configures devices across your enterprise, you can allow your app to be configured remotely. So you can expose a configuration file, an XML app restrictions file that says, these are the following values that we want to be able to set. And then when the user starts up their device and that app is installed automatically, it already has the settings and your app can configure itself appropriately. So like if you're, if you're an app that has, you want to use the same master key for all of them, you can set the key alias in there, for example, and then your app would just use that key. And that way you can kind of control it remotely or from like an IT perspective if you want to. Really quick, here's an example. We call this master key alias, and there's a description for that as well. It's kind of similar to all the other XML Android uses, except in this case, it's just going to be talking about what can be exposed. And this file will be read by the Play APIs and exposed through an EMM console to your EMM if you have one. Really quick, like to use manage config, it's in the restrictions manager, and you get an app bundle when you start your application. And restriction manager get application restrictions will just give you a bundle. That bundle will be the key value pairs that have been set remotely if they have existed. There's also a broadcast receiver you can use to listen for updates. So if someone's remotely changing your settings in your app, you can listen for those and update your app settings accordingly. One last thing, we've all, just kind of going through a few things that we've had a couple issues with lately, and that's private applications. If your company is building apps, or if you're building company apps like internally, and they're never going to be public, they're never going to be for the, they're never going to be published in the Play Store. People aren't going to get them on purpose. It's only for like employees. There's a concept of like permanently private apps, and you have to create those with an Android publishing API. So you can't go create them normally in the console like you would a regular app. In fact, if you create it normally, it won't work this way. So this has been added to Fastlane, and it's also an API that's on the developer side as well. But if one of the differences here is that apps deploy instantly, there's no real checks, and they're not subject to the minimum API level. So if you have like older company apps that are only used by a few people and you need to publish them because you're migrating to managed Play, this would be something good to take a look at. Okay, well, thank you. I'm around. I'll be around the next couple days, so if you have any questions or want to chat, just feel free to come up and say hi. All right.